All right, so picture this. You're in Japan. It's May, and you're hoping to catch a glimpse of the northern lights. You're probably expecting that classic red glow, right? But then something totally unexpected happens. You see this vibrant pink aurora all night long. And then just before midnight, bam, a tall BLU aurora pops up.
Yeah, that's pretty wild. And it wasn't just a one-off pretty kind of thing. This actually happened on May 11th.
Wow.
And scientists are finding it really tough to explain.
Really?
It kind of throws a wrench into what we thought we knew about auroras, especially those happening as far south as Japan.
And here's the kicker. We're always saying citizen science is cool. Well, this is a prime example.
Absolutely.
People were snapping pics and videos of this blue aurora.
Yeah.
And that data helped researchers map it out in a way they never could have done on their own. Talk about a space mystery with a public assist.
Exactly. It shows just how valuable those everyday observations can be. The study we're diving into today, it was published in Earth, Planets, and Space. They took those public photos and videos and combined them with readings from a spectrophotometer. Which is a fancy way of saying they measured light intensity.
Okay.
So now they've got this super detailed view of what this blue aurora actually looked like, and that's where things get really interesting.
Okay, let's unpack that. We're talking structure here, right? This wasn't just a shapeless blob of blue light.
Definitely not. The researchers found these longitudinal structures, almost like stripes, running through the aurora, and they're lined up perfectly with Earth's magnetic field lines. Now, that's something we haven't seen before at these low latitudes, especially with the blue aurora.
Hold on. So we've got a blue aurora, already unusual, but it's also UGE and organized in this way we've never documented before.
Right.
Okay, color me intrigued, because that raises a bunch of questions. Like, we know the typical red auroras happen because of oxygen up high in the atmosphere.
Right.
So what's making these ones blue, and how do we explain those distinct structures?
Well, the go-to explanation for auroras this far south is usually energetic neutral atoms, or ENAs.
ENAs.
They come from Earth's ring current, which is this donut-shaped region of charged particles circling our planet, held in place by our magnetic field.
Okay, ENAs got it. They sound mischievous.
Yeah, a little bit.
But what's the connection between them and auroras?
During something like a geomagnetic storm, which is what was happening when this blue aurora appeared, the ring current gets all riled up. That's when ENAs can get flung towards Earth, smack into the atmosphere, and create the light show we call an aurora.
So at first glance, it seems like a pretty simple explanation, right? ENAs equal auroras, mystery solved. But I'm guessing it's not that straightforward.
You're catching on. While ENAs are often the culprit, a few things about this case don't line up.
Oh, really?
Those stripes, those longitudinal structures aligned with the magnetic field, that's not something we typically see with ENAs. It's like they're following a roadmap we didn't know existed.
Okay, intriguing. Plus, didn't you mention earlier that this aurora was huge GE?
Right. We're talking 1,200 kilometers long and reaching heights between 400 and 900 kilometers. And within that, it wasn't just one uniform structure. It had 3 distinct sections, each with its own characteristics. That really makes it tough to pin on ENAs alone. They just don't behave that way, at least not in a way we currently understand.
So if ENAs aren't the whole story, what else could be causing these blue auroras and those unusual formations? What other theories are scientists exploring?
Another possibility researchers considered was something called resonant scattering of nitrogen molecular ions.
It's a mouthful, ain't it?
It is a mouthful, I know.
Break it down. What's happening there?
Essentially, sunlight can hit nitrogen ions in the atmosphere.
Okay.
And if the conditions are right, that interaction can produce a blue glow. Sounds promising, right?
Yeah.
But here's the issue. During this event, the study found that sunlight was only reaching down to about 700 kilometers.
Right.
Remember, this blue aurora extended much lower, all the way to 400 kilometers?
Yeah.
So that theory hits a snag, too. It can't explain those lower portions of the blue aurora.
All right, so we've ruled out the usual suspects, ENAs, and this sunlight scattering thing.
Right.
What's left? What are the researchers thinking now?
This is where the mystery deepens. The study proposes that there might be some other process at play, something we haven't figured out yet, that's responsible for these blue auroras. And they're pointing to one particularly puzzling clue, the presence of nitrogen molecular ions at those super high altitudes.
Now, why is that a head-scratcher? Isn't nitrogen all around us down here on Earth?
It is, but nitrogen molecular ions up in the atmosphere are heavier than you might think. They also have really short lifespans, so finding them at those altitudes is strange.
Right.
Gravity should be pulling them down, or they should be breaking apart. The fact that they were hanging out up there playing a part in this blue aurora suggests something unusual, something we don't yet comprehend is keeping them aloft and active.
Okay, this is already blowing my mind.
Yeah.
We've got this stunning blue aurora that's breaking the rules, these nitrogen ions behaving strangely, and a whole lot of questions. It feels like we're teetering on the edge of some major scientific discovery.
Yeah.
But before we go too far down that rabbit hole, can you connect this back to us down here on Earth? Why should we care about these nitrogen ions doing their thing hundreds of kilometers above our heads?
That's a great question, and it's important to remember that what happens up there in space doesn't always stay up there.
Right.
The way these nitrogen molecular ions move and flow out from our atmosphere, it actually plays a big role in things like geomagnetic storms and the overall radiation environment in space.
Wait, so we're talking about those events that can mess with our satellites, communication systems, even power grids, that kind of stuff?
Exactly. Those are all connected to how these nitrogen ions are behaving.
Wow.
So figuring out what's going on with this blue aurora and this mysterious process that's influencing those ions, it's not just about solving a cool space puzzle. It could have real tangible effects on our lives down here.
Wow. I never would have guessed that something as beautiful and seemingly distant as an aurora could have such a direct impact on things we rely on every day. This deep dive is already proving to be a wild ride. We've gone from stunning lights over Japan to these nitrogen ions acting like tiny rebels and the implications for space weather. But I have a feeling we're just getting started, right?
Oh, absolutely. We've only scratched the surface of what this study reveals in the next part. We're going to dive deeper into the implications of this unidentified process and explore how it might be influencing the Earth's atmosphere in ways we never expected.
You know, when we think about space, it's easy to picture this vast emptiness.
Right.
But it's actually buzzing with activity, especially around Earth. And as we've been discussing, those nitrogen molecular ions play a key role in all that action.
Yeah, absolutely.
But I'm still stuck on this whole idea of them being at those high altitudes, seemingly breaking the rules.
Right.
What's the big deal with their location?
It's all about how our atmosphere is structured. Imagine it like a layer cake, right? Each layer has its own distinct ingredients, its own density.
Right.
Nitrogen molecular ions, they're kind of heavy, so we'd normally expect to find them in the lower layers like the batter, but during this blue aurora event, they were way up high, like sprinkles on the frosting.
Okay.
Not where they're supposed to be.
Okay, that's a delicious way to put it. But seriously, what could be pushing these heavy ions up so high? It seems like they're defying gravity.
That's the million-dollar question. The study suggests that there must be some unknown force, some hidden mechanism at work that's capable of accelerating these ions upwards. And that's what's so exciting. This could be a completely new process, something we've never even considered before.
So this mystery goes beyond just figuring out what makes these auroras blue.
Right.
We're talking about a potential gap in our understanding of how things work up there. But what are the broader implications of this unidentified process? You mentioned earlier that it could affect things like space weather.
If we connect this back to the bigger picture, understanding how these nitrogen ions behave, especially at those high altitudes, is crucial for understanding space weather as a whole. These ions are interacting with Earth's magnetic field and the solar wind, that constant stream of charged particles coming from the sun.
Right.
And those interactions can have a domino effect, triggering everything from geomagnetic storms that can mess with our satellites to the beautiful aurora displays we love.
So cracking this blue aurora code could actually help us predict and even mitigate the effects of space weather here on Earth. That's a pretty big deal.
Absolutely. It's like we've found a missing piece of the puzzle, and the more we learn about these fundamental processes, the better we can protect our technology and infrastructure from the sometimes unpredictable nature of space.
Okay, I'm getting that this is important, but it's still a bit abstract.
Sure.
Can you give me some specific examples of how this could play out in our everyday lives? What difference could understanding nitrogen ion outflow actually make?
Sure. Let's take GPS, for example. It relies on a network of satellites, right? And those satellites are vulnerable to disruptions from space weather. If we can better predict when and where those disruptions might occur, we can take steps to protect our GPS systems. Right? And that's important because we rely on GPS for everything from navigation to financial transactions.
So next time my GPS goes haywire, I can blame it on mischievous nitrogen ions.
Exactly. But it's not just GPS power grids are another example. Intense geomagnetic storms can induce currents in power lines, which can lead to blackouts.
Oh, wow.
Understanding the role of nitrogen ions in these storms could help us develop better early warning systems and protective measures for our power infrastructure.
This is making me realize how interconnected everything is. We take things like GPS and electricity for granted, but they're actually reliant on these complex processes happening in space.
That's exactly right. And that's what makes this blue aurora mystery so compelling.
Right.
It's not just a scientific curiosity. It has the potential to unlock a deeper understanding of space weather and its direct impact on our lives here on Earth.
I'm already feeling a lot more knowledgeable about auroras and space weather, but you mentioned there's even more to this study, something about the implications for our understanding of Earth's atmosphere as a whole.
That's right. Remember how we talked about the atmosphere as a layered cake?
Yeah, the sprinkles and the frosting.
Well, those nitrogen ions acting like rogue sprinkles could actually be telling us something crucial about how those layers interact and how energy is transferred between them.
Okay, now we're really getting into the nitty-gritty of the atmosphere. So it's not just about what's happening way up high where auroras form,
Right.
but also about how those events are connected to the lower layers where we live.
Precisely. This study suggests a more dynamic and interconnected atmosphere than we previously thought, and that has implications for everything from our daily weather patterns to the long-term effects of climate change.
Wow, this research is really making us rethink some of our assumptions. We're not just talking about isolated events anymore. It's about seeing the Earth's systems as a whole.
You're getting it. And that's what makes this so groundbreaking. It's forcing us to look at the bigger picture, to consider how seemingly unrelated phenomena are actually connected. But there's one more crucial aspect we need to explore, and it has to do with the energy transfer between the layers of our atmosphere. It's like those nitrogen ions hold the key to understanding a hidden language of energy flow.
Okay, this sounds like we're going even deeper into the mysteries of the atmosphere.
Don't worry.
What have you uncovered about this energy transfer? Right. You've really got me hooked on this whole nitrogen ions as messengers idea.
Yeah.
It's like they're revealing this secret language of energy exchange happening between the layers of our atmosphere. Tell me more. How does this energy transfer actually work?
Well, picture those nitrogen ions energized by this unknown process moving from the upper atmosphere down to lower levels. They're like tiny couriers carrying energy packets.
Okay.
And when they collide with other particles in the lower atmosphere, they transfer that energy, creating a ripple effect that can influence wind patterns, temperature gradients, and even the formation of clouds.
So something happening hundreds of kilometers above Earth could be stirring things up down here. It's pretty mind-blowing. What are the implications of this discovery?
It means we may need to adjust our understanding of how the atmosphere works as a whole system.
Right.
You know, we've traditionally studied different atmospheric layers in isolation, but this research suggests that what happens in one layer can have a direct impact on others. And that's a game changer for things like weather forecasting and climate modeling.
I can see how that would be a big deal. If we can understand these subtle energy connections, we might be able to predict weather patterns with more accuracy or even anticipate long-term climate shifts. This is all starting to feel very interconnected.
Exactly. And that's the beauty of this research. It's highlighting the interconnectedness of Earth's systems.
Right.
It's forcing us to see the atmosphere not just as a series of layers, but as a dynamic, interwoven tapestry where every thread plays a role. And those nitrogen ions energized by this unknown process are helping us to understand how the patterns of that tapestry are formed.
This deep dive has been a whirlwind of information, and it's really changed the way I think about auroras.
Me too.
We started with these stunning blue lights over Japan, and we've ended up exploring space, weather, atmospheric energy transfer, and the interconnectedness of Earth's systems.
Yeah, it's amazing.
It's amazing how one event can lead to so many questions and new avenues of research.
It really shows the power of scientific inquiry, doesn't it? We started with an observation that didn't fit the mold, and by following the trail of clues, we've stumbled upon a potential paradigm shift in our understanding of the atmosphere.
Right.
And it all started with those nitrogen ions acting like tiny rebels, refusing to follow the rules.
So what happens next? Where do we go from here? What are the key takeaways for our listeners?
Well, first and foremost, this study is a call to action for more research.
Okay.
We need to study these blue auroras, especially at lower latitudes,
Right.
to gather more data and see if we can pinpoint the mechanism driving this unusual nitrogen ion behavior.
It sounds like we need more citizen scientists out there capturing these events on camera.
Absolutely. Every photo and video helps build the bigger picture. And for our listeners, the takeaway is this: next time you see an aurora, don't just admire its beauty. Wow. Think about the unseen forces at play, the intricate dance of particles and energy that create this celestial spectacle. It's a reminder that even the most familiar things can hold profound mysteries, and that the pursuit of knowledge is a journey without end.
I love that we've gone from a seemingly simple question, why is this aurora blue, to a much deeper exploration of the universe and our place within it. This has been an incredible deep dive, and I can't wait to see what other secrets those nitrogen ions reveal in the years to come.
Me too. And who knows, maybe one of our listeners will be the one to unlock the next big discovery.
That's a fantastic thought to end on. So to all our listeners out there, stay curious, keep exploring, and never stop asking questions. You never know what amazing discoveries await.
And as always, keep looking up.
That's it for this deep dive. Thanks for joining us.